So it appears that the first part of this video had some technical issues. So what I'm going to do is I'm going to leave our results up here again and discuss them very quickly. You'll notice that in the first example, everything was growing at a rate of +8, which made it linear. The second example, if I tried to grow by adding, it was +6, +12, +24, so I knew it wasn't growing at a constant rate of change. What I did find, though, is that you could identify a ×2 pattern if you realize this last spot was a typo, giving us a scale of 2. The last one, 30 over 20, gives me 1.5. 45 over 30 gives me 1.5. 67.5 over 45 gives me 1.5. And 101.25 over 67.5 gives me 1.5 as well. We're multiplying by 1.5 every time we go another step further. There again, that's how we're going to tell the difference between linear and exponential. One's growing at a constant rate, the other's growing by a constant factor. The second thing you're going to be expected to do is if we give you a value of x, you should be able to plug it into an exponential function and calculate a value for y. In this case, -2 times 5 to the third. 5 to the third is 125, which makes this -250. Easy enough. In the next example, 3 times 0.05 to the -2nd, y equals 3 times. Now this one's a little interesting because this is 1/2 to the -2nd. A negative exponent says use the reciprocal. So this is actually 3 times 2 squared. 2 squared is 4 times 3 makes 12. For example C, 2 times 9 to the -2nd. That negative sign says use the reciprocal. So this is 2 times 1/9 squared. Well, 1/9 squared is 1 over 81, which makes this 2 over 81. And finally, y equals 1.5 times 2 to the 1/2 power. You will remember from our exponents unit that this is 1.5 times the square root of 2. Now, I don't happen to know the square root of 2 off the top of my head, so I'm going to grab my calculator and do the square root of 2, which is, according to my calculator, in a different form. One moment. Let's try this again. Square root of 2 is 1.41213 blah, 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 times the 1.5. Comes out as about 2.12. There again, I don't expect this portion to be too terribly difficult. Last thing we need to do is we should be able to describe the effect of a transformation on the graph of an exponential function. Thinking back to our functions unit, we discussed vertex form of lots of different functions, and what we learned is the thing that's in the A position always controls the steepness of our graph. Whatever's inside with the X controls left and right movement. And we said that it's always the opposite of what we think it's going to be. And K controls the up and down motion of our graph. So that if I were to multiply g of x equals 2 to the x power by a 4, or put a 4 in the A position, my graph is going to get steeper. If I were to put a 1/2 in for my B position, this is new. The B position is going to change the direction. Didn't really address that a second ago. You'll notice that if I'm cutting in half, instead of growing, I'm shrinking. And in the case of a negative, it reflects across the asymptote. So what that's going to look like is this. If I have 4 times 2 to the x minus 3 plus 2, the first thing I'm going to realize is that my asymptote is going to go up 2 spaces. So I'm going to draw that. There's 0, 1, 2. And there I go. right there. The second thing I notice is that I have an x minus 3. Remember, when you see that minus 3, you expect to move left. It actually is going to move the whole thing to the right. 1, 2, 3 spaces. So I'm going to focus my attention over here. And I notice that the steepness is 4 times as steep as it ordinarily would be. So I already have a pretty good idea of what's going on. I didn't address that 3 right there in the middle, but I will talk about that. That 3 is my base number. Since it is a positive base number, I'm going to expect it to go just like it normally does, making that curve. So, starting with 3, if I were to make a table, 3 minus 3 is 0. 3 to the 0 is 1. 1 times 4 is 4. 4 plus 2 is 6. So I'm going to start this off at 3, 6. If I were to put in a 4, 4 minus 3 is 1. 3 to the first is 3. 3 times 4 is 12. 12 plus 2 is 14. 4, 10, 11, 12, 13, 14. I'm going to call that one right here. Let's go back the other way. If I put in a 2, 2 minus 3 is negative 1. 3 to the negative 1 is 1/3. 4 times 1/3 is 1 1/3, plus 2 is 3 1/3. 2 goes to 3 1/3. And let's go one more time. Let's go with a 1. 1 minus 3 is negative 2. 3 to the negative 2 is 1/9. 4 to the 1/9, or times 1/9 is 4/9 plus 2 is 2 1/9. And you can begin to see your graph taking shape. I've got negative 2 times 3 to the x plus 2. Let's see if I can get that to focus again. Minus 1. This is going to tell me that my asymptote is down 1 spot from where it normally would be. So I'm going to fill that in. Like this. I can see that I have a plus 2. Since it's x plus 2, I know that I'm going to want to be working over here 2 spaces to the left. I'm going to be looking in this area. The 3 tells me that it's going to grow by a factor of 3, and negative 2 tells me that we're going to be doubling everything and flipping it over. That's going to be important right there with the negative sign. So let's go through, and we're going to start making our x and y chart. Starting with the negative 2. Negative 2 plus 2 is 0. 3 to the 0 is 1. Negative 2 times 1 is negative 2. Minus 1 gives me negative 3. So negative 2, negative 3. If I put in a negative 1, negative 1 plus 2 is 1. 3 to the first is 3 times negative 2 is negative 6. Minus 1 makes negative 7. Right there. If I put in a 0, 0 plus 2 is 2, 3 squared is 9, 9 times negative 2 is negative 18, minus 1 makes negative 19, which means I'm going to be way off my graph. The good news is, I have a pretty good idea what's going on there. I'm going to go ahead and stick in a negative 3, just to give me one more point here. Negative 3 plus 2 is negative 1. 3 to the negative 1 is 1/3. Times negative 2 is negative 2/3. Minus 1 is negative 1 2/3. I think from there we're pretty safe to draw that graph out. I just now realized that entire graph was off screen. Sorry about that. Last one I notice. This one is going to have an asymptote that's up 3 places. So I'm going to do a horizontal asymptote at 3. That looks right here. Notice it doesn't go left or right at all, so I'm just going to start off at 0. when I make my table. And notice that this is a decimal, 1/4. That means instead of growing by a factor of 2 every time, it's going to be growing by a factor of 1/4 every time. That means instead of my graph going up, I can expect my graph to come down, because multiplying by 1/4 makes things get smaller. If I put in a 0, 1/4 to the 0 is 1 plus 3 is 4. If I put in a 1, 1/4 to the first is 1/4 plus 3 is 3 1/4. Now I'm not going to make much progress going that way. Let's go to a -1. 1/4 to the -1 says use the reciprocal of 1/4, which is 4, plus 3 makes 7. On 7, there we go. And I'll go ahead and do a -2. 1/4 to the -2 says use the reciprocal, so 4 squared is 16 plus 3 is 19. Your graph is going to come right about like that. Hopefully that gives you enough to work with. There again, this is just a review of what we've done before, and then a little bit of extension. Notice that our graphs are going a lot more directions than they were going before. You do have an assignment. It is out of your textbook. It is on the first slide. So best of luck. Thank you. Bye.